Alright, so I'm into the third session today for It's Not Complicated Tutoring, and I have my other client, Miss Miri here. So we've been working on basically polynomials for the past couple sessions, synthetic division and long division. So the synthetic division and long division lesson went pretty well. I think she pretty much favored the synthetic side, right? Mm-hmm. Synthetic division was favored better. So, and that's the fact with everybody, even the people that I teach or the students that I teach at Peak and in Cedar Hill, it was the same thing. They all like the synthetic division. So we're going to proceed further today on polynomials and go with the lesson from there. So the first thing we're going to look at is polynomials in one variable. Alright, a polynomial of degree n in one variable x is an expression of the format a. Really, it's decreasing order from highest exponent to lowest exponent. So the a to the n, or a sub n rather, x to the n, right, and then plus a to the n minus 1, or a sub n minus 1, x to the n minus 1. And it's going to keep continuing all the way until pretty much forever, wherever you end at. And it'll be a sub 2 x squared, and then plus a sub 1 x to the 1, which is basically just x, plus a sub 0. That gives you all the way down to the basic bottom of polynomials in one variable. So the coefficients represent real numbers, obviously. So coefficients are real numbers, okay? And n is a non-negative integer. So n is non-negative. N is non-negative. Now, an example of a polynomial would be something like this, right? 3x to the 5th plus 2x, 2x to the 4th minus 5x cubed. I'm sorry, minus, I can just put 5x cubed plus 2x squared minus 5x plus 1. Something like that. Now, as you see, right, the exponents, they're going decreasing order, right? So you have 5, 4, 3, 2, 1, 0. Okay, that's how all polynomials run as far as the order of the exponents. All right, never go up from 1, 2, 3, 4, 5. Always go down from 5, 4, 3, 2, 1. Make sense? Okay, now, find the degrees and leading coefficients. So if I have a polynomial of 7z cubed minus 4z squared plus z. All right, what do you think? First of all, is it a polynomial in one variable?
It looks like.
Did you see anything else besides z?
Oh, no.
No, right? All right, so it is a polynomial, right? We talked before about having a negative exponent is not a polynomial because it goes down to the denominator, right? So the degree of this is going to be what? Of this whole thing, what would I say the degree is?
What do you mean?
Like the highest, in other words, what is the highest exponent of this whole thing?
3.
3, right? Because there's two different ways. Remember we talked about this, where the polynomial 3 is the highest here, highest exponent, largest exponent, or however you want to say it. But if I had something like this, 7z squared y cubed s squared, the degree of this is I add all of the exponents up. And then we talked about that for one monomial. So this degree would be 3, 4, 5, 6, 7. It would be degree 7. But that's degree 3. But bless you. That's degree 3, right? So each monomial, we have 3 for this monomial. Alright, we have 2 for this monomial and 1 for that monomial. 4 doesn't have a degree, it's a number. Make sense? So the degree of this one is going to be 3. The leading coefficient is 7 because that's what's in front of the z, of the whole thing, right? What about that one? What do you think about that one? First of all, is it a polynomial in one variable? Let's look at that first.
No.
Huh?
No.
No, right? Because of the last monomial, right? So AB squared compared to the A squared and the A cubed is not one variable, it's two variables. All right, good. What about that? State the degree and leading coefficient of 3x cubed plus 2x squared minus 3. So 3x cubed plus 2x squared minus 3. What is my leading? What I like to call the LC? What's the LC and what's the degree?
I think it's B.
B? So the degree will be 3, right? Which is good. So degree 3. And the LC is 3 also, because that's what's leading the whole thing. Right? Don't worry about 2, don't worry about negative 3. It's whatever's leading the actual polynomial is what's my leading coefficient. So it is, in case, answer choice B. Okay? Any questions on that stuff? Pretty simple, right? Okay. How about that one? Can I even do that one?
No.
Because?
The X and the Y.
Alright, X and the Y, right? Good. Okay. Alright, so now, the definition of a polynomial function of degree n is a continuous function that can just be described by the equation. The same thing we saw earlier up on top is kind of similar to what the equation is going to be. So all we do is we replace the expression, going from an expression to an equation now. We just say, instead of just saying 2x squared plus 5x plus 1, we now have y equals 2x squared plus 5x plus 1. That's a polynomial equation. Alright, it's not too much of a change, just put y equals there. Okay? So here it says refer to example 2. Well, we don't have the textbook right now in front of me. I have it on the drive, but we may have to skip that particular one. Let me see. Go to the next example. What do we have here? Really? It's like, dang, what's it doing? Okay. There we go. All right. So function values of variables, right? It says find B. I'll erase this part so we can have room. Find B of 2x minus 1 minus 3 of bx if the polynomial bm equals 2m squared plus m minus 1. Okay, so what do you think we do first? What do you think we do first? I want to find b of 2x minus 1 minus 3 times b of x if this is my function right here. So the first thing I'm going to do is write my function down. It's already there, right? Then I want to plug in 2x minus 1. Right? This is saying I got to plug in. Actually, let me get another color. This is saying I want to plug in 2x minus 1 into everywhere I see m. Okay? So in this case, it would be 2 times 2x minus 1 squared plus 2x minus 1 minus 1. Alright? Now, what would 2x minus 1 squared be if you foiled it out? All the way. I have to work that out. And as y'all see over there in the world, right? If you look up there, you have the equation that you need to plug the values in. That's how it works when you have certain, plug in f of 2x or f of 3x. You always plug in what's inside the parentheses into the equation wherever you see x, just to FYI. We get
4x squared minus 4x plus 1.
alright, so 4x squared minus 4x, you said?
Yes, plus 1.
Alright, so let's see, let's double check that. So we know 2x minus 1 squared is going to be 2x minus 1 times 2x minus 1, right? Off top. So it's 2 times 4x squared minus 4x plus 1, right? Is that what you got? Or did you get something different?
No, that's what I got.
Okay. Alright, so then we need plus 2x minus 1 minus 1. Alright. And this goes into, now I distribute, right? All of these together. So I'm going to get 2 times 4 is what?
8.
8x squared minus 2 times 4 is 8 again, minus 8x plus 2 plus 2x minus 1 minus 1. Now, mind you, it says minus 3 times bx, right? So, in x, I should have used x, or I should have used, no, I'm good on the x. I want to make sure I had the right variable in. So, it says minus 3 times bx, right? So, when I do the minus 3, I then plug in, and let's see if it matches here, right? 8x squared minus 8x plus 2 plus 2x minus 1 minus 1, right? We evaluate that. We're going to get 8x squared minus, now I combine like terms here, and minus 8 plus 2 is going to give me
6.
negative 6, and then plus 2 minus 1 minus 1 really cancels itself out, right? Because 2 minus 2 is 0. So that's my first portion. Now it says minus 3 times bx. So I replace the m with the x, obviously, right? And then I plug in 3 times 2x. X squared plus x minus 1. And I distribute. So if I distribute, what do I get now? Or what does that simplify to?
6x squared plus 3x minus 3.
Alright, outstanding, good. Now it says minus this whole thing, so now I take this minus all of that. Gotta make sure it's in brackets because I don't want to jack up my sign, right? So technically you have 8x squared minus 6x squared, which is what?
Negative 6, or no, you said
8x squared minus 6x squared here. Come on, like terms,
yeah.
right? So what do you get?
Do you
Keep up, right?
do you distribute the negative first, or
Yes.
okay?
Fake like it's a 1, like a imaginary ghost right there, right?
Okay, so it's like negative 6x squared.
Mm-hmm. So 8x squared minus 6x squared, right? Which is
2x squared.
2x squared, and then minus
3x, so it's negative 9x
negative 9x, and then
plus 3.
negative is a positive, so it's plus 3, right? And that's our final answer for that one. Does that make sense? Okay, so that will be the first half, right? The first video of it. So of this particular problem, and we completed the function value of variables and evaluated them to the final answer of 2x squared minus 9x plus 3. And we'll continue shortly.